Do you ever feel like a large language model is ignoring parts of your prompts? Maybe you have a large prompt with a lot of different instructions and it can't really seem to adhere to all of them. Or you're passing in a lot of context, like passing in a list of buildings in a JSON format. Maybe you tried some of the common prompt engineering techniques, such as few shot or multi-shot prompting, where you put in examples into the prompt to make sure it understands what to do, but still, in some cases, the LLM falls short of following the instructions. This is when converting your prompt into XML can be a game changer. And this is according to Anthropic, who develops Claude. They put out this document saying you should convert your prompt into using XML tags, which will help Claude parse your prompts more accurately, leading to higher quality outputs. Now, they say this specifically for Claude, but I've tried this with Gemini, GPT as well, and I can confirm that it works across models. And the reason behind why it works is kind of straightforward. For example, in my Condo GPT project, I have this massive prompt with a bunch of instructions, even examples, and large SQL queries. This leads to the agent not necessarily remembering all the context or all the rules are defined, which means I have to specify a bunch of times, important in caps lock, but it still misses these rules sometime. Now, I actually took this prompt and using a little bit of help from Claude, converted it into XML to kind of give you an example of how this looks like. So if you've done any HTML programming, then this will be pretty easy for you to understand. So same thing here, we have a tag and an opening tag and then a closing tag. So here I want for the role and the task. You can put anything you want in these tags, honestly, as long as it's like easy to comprehend English. So we can see as you're kind of categorizing all of your requirements into constraints, task, processes, available context, etc. And this makes it easier for the LLM to know when one instruction starts and when it ends. So why does this make such a big difference? It all goes down to how LLMs parse information. So with that XML structure, the model sees a wall of text and must infer relationships between different parts. Here's where instructions can blend with examples and context can mix with constraints. This means also that the model expends some cognitive effort by trying to decipher, is this an instruction, is this a role, is this piece of text in conjunction with the text before it? And due to the non-deterministic nature of LLMs, this can lead to it reading the instructions clearly one time and then another time it misinterprets the instructions. Now with the XML structure, we have a clear hierarchical boundary to help the model immediately understand the role of each section. So we have the start and the end. And then the LLM knows that everything inside that tag is related to the tag itself. And it reduces ambiguity about whether something is an instruction, example, or context because we are explicitly defining it and wrapping it inside the tags. And it creates explicit semantic relationships between these different parts. These tags can help the model quickly locate relevant information for the current task, understand which parts of the prompt to prioritize, and maintain context about the relationship between different sections. I think this is a great analogy. Imagine reading a research paper with no headings, formatting, or structure, and then you read the same paper with clear sections, headers, and organized references. In the first example, it's way easier for you to get lost, right? Whereas in the second, you know exactly the section you're reading, what it's about, and when that section ends. And here's just a very brief example. So here we have an instruction, and in the instruction, we have an example. Now, a better way of prompting this is to have the role, the instruction, the example, and then the rest all laid out like this. Some other measurable benefits of this is reduced hallucination because there's less guessing about what the prompt is intended to do. You'll probably see an improved consistency. And as you're working on improving the prompt, it's way easier to iterate on it and improve it because you can modify one section without breaking the others down. So kind of separating your prompt into unique parts. A very important principle in AI engineering is just, separating things into their own sections. This was like the first AI project I did, and as you can see, it's just one behemoth of a prompt. Ideally, you want to break this out into probably multiple LLM calls, because that's just a very useful principle in AI engineering, is to make things modular. So this is one call that achieves a lot of things. Breaking it out into multiple calls that call each other, that are specialized in one thing in particular, will lead to a much better performance. And it's the same principle here, just breaking stuff out in general and separating them. So what sort of tags can you use? Well, it seems you can pretty much use any tags you want, as there's no canonical best XML tags. But Anthropic recommends that your tag names make sense with the information they surround. And some best practices are be consistent, so use the same tag names throughout your prompts and refer to those tag names when talking about the contents. You can reference sections inside other sections, which is another great benefit of this. And you can also nest tags for hierarchical content, and this is actually recommended. Here's a power user tip for making high performance prompts. If you combine XML tags with other techniques like multi-shot prompting or chain of thought, this will really get you some super structured and high performing prompts. So this technique has actually helped myself in my work, where I develop an AI agent for e-commerce that basically analyzes different products in a JSON format. And when I have a big prompt there with a lot of rules, what I did is I ended up breaking it out into sections separated by XML tags. And I saw that before it would ignore certain instructions on certain runs, whereas now it knows exactly what instructions are where, what its role is, and what the restraints are, and it follows them quite well. So this technique, while it does add some potential tokens to your prompt, the benefits are really good. And we use GPT-4 at work. So anyway, I just wanted to share this quick little tip that's helped me a lot. I think it's very interesting. And I highly recommend you read through the Claude docs and the Anthropic blog, because they share a bunch of these nuggets of information that can really help you with engineering AI applications. Thank you so much, and I'll see you later.